Welcome to SAT School. I am your instructor from satschool.com. This is our fifth video on set. In this video, we will discuss on complement of set. Now let's get started. First thing first, let's have a look at the practice question that I gave you in previous video. If you have not watched that video, I strongly recommend to watch that first. Click the I button above and watch the video. I hope you manage this question. If not, let's have a look. Here, Na, the cardinal number of A is 45, the cardinal number of Nb is 65, and the cardinal number of A union B is 85. Now the question is to find the cardinal number of A intersection B and the cardinal number of only B. Now the given is Na 45, Nb 65, and Na union B 85. Now we have already discussed the cardinal property of sets. According to cardinal property of set, N A union B is equals to Na plus Nb minus Na intersection B. That is the sum of cardinal number of set A and set B minus intersection A intersection B. That is a cardinal number of A intersection B. Now we have the value of Na, Nb, and Na union B, which is 45, 65, and 85. Here we brought the cardinal number of A intersection B to left hand side. So we have to change the sign from minus to plus. Similarly, Na union B is brought to right hand side. So there is minus 85. Now to find Na intersection B, sum 45 and 85 and then sum 45 and 65 and then subtract 85, and that gives you Na intersection B, which is 25. Now the second question is to find the cardinal number of only B, and to find cardinal number of only B, we subtract cardinal number of A intersection B from cardinal number of B. So we use the cardinal property to find only B, that is N not B is NB minus NA intersection B, and the value of NA intersection B is 25. We calculate above, which is 25. Now NB is given, which is 65, and NA intersection B is 25, and that gives you the value 40. So if you manage this, then congratulations. Let's move forward. Now here, complement of sets. Let U be universal set and A be subset of universal set. Then the complement of set A is a set of all elements of U which are not the elements of A. Meaning, to find complement of any set, we have to find the difference of that set from universal set. Here, symbolically, we write complement of A as A dash. Now, to find out complement of A, we use U minus A. So this is nothing but the difference of set A from universal set. Meaning, to find a complement of A, you just have to subtract all the common elements of A from universal set. Here is an example. U is 1, 2, 3, 4, 5, 6 and A is 2, 4, 6. Now let's have a look at the Venn diagram to find complement of A. Here U represents the universal set and we have A as 2, 4, 6. So these are elements of set A. Now U is 1, 2, 3, 4, 5, 6. As set A already contains 2, 4 and 6, 3 elements, the remaining elements now will be 1, 3 and 5. So there is a elements of set U, which is the elements 1, 3, 5 as well as elements of set A. So all together we get 1, 2, 3, 4, 5 and 6. So the set A is 2, 4, 6, and now the elements 1, 3 and 5. So that represents complement of A. So this is how we can show by Venn diagram. Now let's calculate. Here we have U is 1, 2, 3, 4, 5, 6 and set A is 2, 4, 6. Now when you subtract 2, 4, 6 from complement, from universal set, then the remaining elements will be now 1, 3, 5. I repeat, to find complement of any set, you just have to find the difference of that set from the universal set. Now what happens to what happens if we have to find the complement of A union B or the complement of A intersection B? Now let U be 1, 2, 3, 4, 5, 6 and A and B are two given sets. Now how to find complement of A union B? So to find the complement of A union B, let's have a look at a Venn diagram. We have A union B, which is 1, 3, 5, 4, 6. So this is A union B, meaning the combination of all the elements from set A and set B. And union of A and B is 1, 2, 3, 4, 6. Now let's have a look at the universal set, which contains elements 1, 2, 3, 4, 5, 6. Now since elements 1, 2, 3, 4, 6 are already in A union B, now the remaining element is 5, and that represents the complement of A union B. Now let's calculate now. To find complement of A union B, we subtract A union B from universal set. We have universal set as 1, 2, 3, 4, 5, 6, and that is the value of A union B, which is 1, 2, 3, 4, 6. Now these are the common elements that you can subtract from universal set, and that gives you only 5. So this is how we can find the complement of A union B. And even you can find the complement of A intersection B. You can try that. Now here is a practice question. A and B are two subsets of universal set. Here the cardinal number of universal set is 43, NA is 25, NB 18, and NA intersection B is 7. Now the question is to find Now the question is to show the above information by the Venn diagram, and again to find the complement of cardinal number of A union B. So I want you to pause the video, at least you give a try, and I'll be back in a moment. Welcome back. I hope you managed that. Now let's see. So these are given information. NU43, the cardinal number of universal set, NA25, NB18, and NA intersection B 7. So we have universal set and A union B. The A loop section represents the intersection of A union B. So that is the cardinal number of A intersection B. We have NA, NB, and NA intersection B. So to fill in the Venn diagram, let's find out first NA intersection B. That is a cardinal number of A intersection B, which is 7. So the cardinal number of NA intersection B is 7. Now the green section represents only A, which is different from NA. So the green section is N not A, and using cardinal property, N not A is NA minus NA intersection B. We have the value of NA, which is 25, and NA intersection B, which is 7, and that gives you 18. So the 18 is the green section, which is only A or n not A. Now look at 18 plus 7, which is 25, and that is the cardinal number of set A. So NA is 25, and that is a sum of 18 and 7. Similarly, the red section represents only B, and to find only B, we have a cardinal property n not B is NA, sorry, NB minus NA intersection B. Here NB is 18 and NA intersection B is 7, and that gives you 11. So the red section is 11. The red section represents only B or n not B. Now if you sum 7 and 11, that is 18, which is the value of NB, the cardinal number of B. Now if you sum 18, 7 and 11, that gives you 36. Now we have NU 43, which is given. The cardinal number of universal set is given 43, and that is a sum of all sets. Now here, to get universal set, we need 7 outside A union B. I mean the cardinal number of A union B. Again, the cardinal number of A union B is the sum of 18, 7 and 11, which is 36. So 7 is the complement of A union B, or the cardinal number of A union B. So from the Venn diagram, that 7 represents the cardinal number of A union B. I mean the complement of the cardinal number of A union B. Okay, now the sum of 7, 18, again sum of 7, my bad, the sum of 7, 18, 7, 11, that is all together 43, which is the cardinal number of NU. So this is how we can show the information by the Venn diagram, and we can find the complement of cardinal number of A union B by Venn diagram. Here is one more practice question. In a school, there are 20 teachers who teach mathematics or science. Of these, 12 teach mathematics and 4 teach both science and mathematics. Now the question is, how many teach science? So the first is, let's suppose M be the set of teachers who teach mathematics, and S be the set of teachers who teach science. So M represents set of teachers who teach mathematics, and S represents set of teacher who teach science. So the first thing that you have to find out is some keyword. Here OR gives you the hints for union. So in the question it says 20 teachers who teach mathematics or science. So that 20 represents the union for M and S. Okay, set M, that is the set for teacher who teach mathematics. Set U is the set for teacher who teach science. So OR is a keyword, and that keyword represents for union. That means 20 is the union of M and S. Again, the next keyword is both. Here in the question it says 4 teach both science and mathematics. So the both keyword that represents the intersection. Here 4 is the intersection of M and S. So remember these keywords, or that represents union, and both that represents intersection. So you can now write by notation like N M union S is 20. The cardinal number of M union S is 20. Again, in the question, 20 teachers who teach mathematics or science. And the or represents union. That's why the cardinal number of M union S is 20 and NM is 12. So it says 12 teach mathematics. So the cardinal number of M is 12. N M is 12. And the 4 is the cardinal number of M intersection S. Both that represents intersection. So remember these keywords or for union and both for intersection. Now the question is to find how many these signs, the cardinal number of S. So you should be comfortable by this time. You should be comfortable using the cardinal property of two sets. So I want you to solve the question. Use the cardinal number of the cardinal properties of two sets and try to find NS, the cardinal number of S, meaning how many teachers are there who teach science. So if your answer is 12, then your answer should be right. So I want you to try the remaining question using the cardinal properties of two sets and try to find NS. Thanks for watching video. If you like the video, don't forget to subscribe and do share and like the video. I'll meet you in next video. Take care.